On November 20th, word came from JPL of a major discovery on Mars. The most recent work done before departing Rocknest was a soil analysis by the SAM instrument. While we do not know the nature of the announcement yet, we were able to talk with Dr. John Grotzinger, the mission scientist for Mars Science Laboratory, to discuss what was done with the soil and where the sample came from.
It looks like a typical kind of a sand dune. It's a little small sand dune, 10 centimeters high kind of thing. But it's a good target to dig into, and so we scoop into it, and then we do two things with it. One is we mostly clean out the Chimera sample processing system because it's got a lot of exposed surface area and it's dirty. So we flush it with the sample and we shake it around, move it around, then we dump it out. Then we take another scoop of soil, put that in, shake it around, dump it out. Then we take the third one, and then the third one finally goes into the ChemIn instrument because it's clean enough for ChemIn, and we got some nice data from that. And then we do a fourth one that we scooped, and then we threw that one away. And now we get our fifth scooped sample that we'll then process and dump into the SAM instrument. So with that, we'll have analyzed the soil with the ChemCam laser, with the APXS instrument, chemical sensor. We'll have analyzed it with ChemIn, X-ray diffraction, and now we'll have looked at it with SAM.
Even as Curiosity departed Rocknest, the sample was being analyzed.
What ChemIn showed us is that the soil has two basic components in it, one of which is our true minerals that have an ordered arrangement of atoms that give you a very particular crystal structure. And then there's a bunch of stuff in there that's X-ray amorphous, meaning that it doesn't have any kind of orderly structure to it, or the orderly elements are so small that they don't diffract X-ray beams. And it's a big question as to what this stuff is. And if we get the APXS analysis of the soil, we can get some sense for what it is. And then you go back and you look at the ChemIn data, and you look quantitatively at how much stuff was actually crystalline, and you know what minerals they are, and you know then what the chemical formula is for the mineral. So then you're able to extract all of those elements that represent those minerals, and then what you're left with is the unknown chemistry of the X-ray amorphous material. And so if we can take that fraction of the sample and then dump it out onto our observation tray, and then put the APXS down on top of it, we can get the chemistry of that fraction that's less than 150 microns that also includes the X-ray amorphous stuff. And then we take that same stuff and we dump that into SAM, and SAM heats it up to 900,000 degrees. And as you do that, the rock decomposes and breaks down, and then the volatiles come off. Let's say that there's a mineral or there's some material in it that is below the detection limit of ChemIn, which is a couple percent. Let's say it's carbonate. And so that mineral, if it's something made out of calcite, it would be calcium plus CO3. So when you take the rock, it's rock hard, you heat it up, it breaks down, and what happens is that calcium carbonate produces carbon dioxide. So we'll drive that off, and we'll see that, and so it comes off as a gas. We'll collect that gas, and then we can analyze it, and we can determine that it's CO2, and we can also measure the isotope ratio of the carbon. It's an amazing amount of stuff that we can do with this rover. We can actually figure out what this really fine-grained stuff is that's swirling all the way around Mars. Once and for all, we'll know what it is.
The first analytical run has been completed, but the results, which Grotzinger called one for the history books, won't be announced until December 3rd or so. We'll keep you updated. This is Rod Pyle for Space.com.
Space.com.